Good morning everyone. My name is Tanushree Dalai from Civil Engineering branch, and today I am going to teach you about your Theory 1 paper which name is Structural Mechanics. Okay, so in the last class we discussed about the chapter 2 which is your stress and strain. So we discussed about what do we mean by stress and types of stress, that is tensile stress, compressive stress and shear stress. Then we just initiate the strain part. So let's start with the strain. So what do we mean by strain? So strain is nothing. It is the ratio of change in dimension to the original dimension of a body which subjected to the loading part. Okay, so the strain also various types. So first one is your tensile strain, next one is your compressive strain, and last one is your shear strain. So first of all, the tensile strain. So what do we mean by tensile strain? You know what do we mean by tensile force? The force which applied to a body by pulling in nature. The force which is pulling in nature is known as your tensile force. So while we give a tensile force to a body, you can see in the figure also, here is the body, and while we provide a load and we give a pulling load, then the length of the body is increased. You can see the length of the body is increased, and one thing is happened, the width of the body is decreased. Okay, so by provide a tensile force to a body, the body subjected to increment of the length and decrement of the width. So we know the strain means change in dimension divided by original dimension. So you can say that by its definition, strain measured under tensile loading is known as tensile strain. It tends to decrease the cross section and increase the length of the body. Okay, so you can say the tensile strain means while a body subjected to a force which is tensile in nature, hence the body subjected to the tensile strain. Okay, so next is your compressive strain. So it is the opposite of the tensile strain. That means when a body subjected to two equal and opposite push, that means pushing force means compressive force. Hence the length of the body is decreased and the width of the body is increased. You can see here the length of the body is decreased here and the width of the body is increased here. So that you can say due to the compressive force, the body gives a strain which known as compressive strain. So by its definition, it says that strain measured under compressive loading is known as compressive strain, and it tends to increase the cross-section area and decrease the length of the body. Okay, so in the next one is your shear strain. So as I said before, in case of shear stress, here also this kind of force is applied, but here the term is different. Like in the stress section we studied about shear stress, but here we will study shear strain. So what do we mean by shear strain? So if it is the body, you can see it is a body and it's subjected to a force which is this kind of nature and another force which is this kind of nature. Hence the body is deformed like this. Okay, due to this force it will be deformed like this, and due to this force it will be deformed like this, and it's situated, it make an angle with respect to the original shape of the body. Okay, and that angle is known as your theta, and the change in length is known as your delta L. Okay, delta means we use the delta for the changing purpose. So here we can say that the change of length is known as your delta L. So by the definition we can say that when the shear stress is applied on a body, it tends to deform the shape of the body as shown in the figure. You can see. Then the change in tangential angle, that angle which make with respect to the original shape of the body, is known as your tangential angle. So the tangential angle in the direction of the loading, which is in this direction and it is in this direction. So loading is called as shear strain. Okay, so you can say that the change in dimension is delta L and the original dimension is L. So we can say that strain equal to change in dimension, which in this situation is delta L, divided by original dimension, which is in this situation is known as only L. So the epsilon shear equal to delta L by normal L. Also you can find out, if you will find out the theta value, okay, then you can easily find out by multiplying tan theta and calculate the value. You can easily find out the shear strain of the body. Okay, if you given by theta value, you can easily find out the tan theta. Then if you will given by delta L value and L value, you can also easily find out the epsilon shear, that means shear strain value. So next one is your mechanical properties of material. Okay, so any kind of material all possesses some properties like your elasticity, plasticity, ductility, brittle. Okay, these are some properties of the material. So according to the type of material, the properties is changes and varies from time to time. So in case of mechanical properties of the material, you will study about various kinds of mechanical properties. Okay, so your first properties is elasticity. So what do we mean by elasticity? Elasticity is the property by virtue of which a material is deformed under the load and is enabled to return to its original dimension when the load is removed. That means whenever a body subjected to the loading system, if it is elastic in nature, then we can say that the body is regain its dimension, its shape and size if the load is removed. Okay, if the body is in elastic zone, then it can regain its dimension while removing the loading system. Okay, so elasticity is a property by which a body can regain its dimension or shape and size by removing the loading system. So this is the mechanical properties of the material. So today class, I wind up this class up to this much. In the next class, I will discuss all the properties of the material. So thank you so much.